Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 4, Lesson 5. Let's get started. Okay, we're learning today about exponents, and when we talk about exponents, we're talking about repeated multiplication. We started the other day talking about repeated addition, so it's going to be imperative that you understand the difference between the two. The opening exercise is just a reminder of the work that we did last time with repeated addition. So take a moment to write these expressions using multiplication, the code that we talked about, so that you change repeated addition into a multiplication expression. All right, so you should have found that we are repeatedly multiplying 4. So the number that we are repeatedly multiplying here is 4, and then we're going to multiply by the number of times that we repeatedly add 4. So if I count these here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times I'm multiplying by 4, or I'm adding 4. So the code is repeatedly add 4 10 times. And that's the multiplication problem that you should have written for the first expression, addition expression. The second one, it's the same code. We're going to repeatedly add 9, and we're going to do that 5 times. So 9 times 5 is the expression. And for the last one, we're going to repeatedly add 10, and we're going to do that 5 times. So 10 times 5 is the multiplication expression. All right, so that's repeated addition is multiplication. And we talked about the existence of repeated multiplication, and we introduced it a little bit, but today we're going to know for sure what everything is when we do repeatedly multiply. So here it's the same idea. We look for the number that we repeatedly multiply. So in example 1, we're going to repeatedly multiply 5. So the 5 is the first number that I put down. That number is called the base. So I'm going to give yourself a note here and write this down so you know when I talk about a base, I'm talking about the number that is repeatedly multiplied, whatever that number happens to be. In this case, it's a 5. Okay? Then we're going to look for the number of times that it's repeatedly multiplied. So I see that I've got 1, 2, 3, 4, 5 times I'm going to multiply 5 together. I'm going to take 5 5s, multiply them all together, and so 5 is the number of 5s I'm multiplying repeatedly, and that goes as a superscript, okay, up above, and that is called an exponent. So make yourself a note. The 5 is called an exponent. Okay, and that's the code. We're instead of 5 times 5 to show repeated addition, now we're going to show repeated multiplication with this code. We're going to use something called an exponent. And all of this together is called a power. All right, so if you see that word, a power, it just means you're going to use a base and an exponent to write a code to show repeated multiplication. All right, so 5 times 5 times 5 times 5 times 5, that's the number 5. That is your base, and it is repeatedly multiplied 5 times. That is your exponent. 5 to the 5th power is how we would say that. Second example, we've got 2 that is being repeatedly multiplied. So 2 is your base, and we are repeatedly multiplying 4 of those 2's together. So 4 is our exponent. 2 to the 4th power is how we would say that. So we're writing each expression here in exponential form. Exponential form just means that there's an exponent involved, and we're writing that code. So we don't have to write 5 times 5 times 5 times 5 times 5. We don't have to write all that out. I can write it in a code showing that it's repeated multiplication, and that code is a power using a base, the number that is being repeatedly multiplied, and the exponent. Okay? Now we're going to go the other way. we're going to start with the exponential form, and we're going to write this in expanded form. So for example number 3, I'm finding the number that is being repeatedly multiplied. Well, that's our base. The base is the number that's being repeatedly multiplied. So in this case, it's an 8. So 8 is my base, and that's the number I'm going to multiply by itself 3 times. So I'm going to have 3 8s. 8 times 8 times 8 would be the expanded form of the code 8 to the third power. We also call 8 to the third power cubed. So there's a couple of shorthand ways to express that. 8 to the third power is 8 cubed. 8 cubed. All right? Next, number 4. The number that is being repeatedly multiplied is a 10. And I'm multiplying 6 of those together. So there's 2, 3, 4, 5, 6. 6 tens multiplied together, that is 10 to the 6th power. And I've just changed from exponential form to expanded form. All right, let's take a look at this next question. What's the difference between 3g and g to the third power, or g cubed? Well, remember, 3g means 3 times g. So I'm taking this code 3g, that means 3 times g, and that is multiplication. Remember, multiplication is a code for repeated addition. Repeated addition. So we're going to repeatedly add g 3 times. So that is repeated addition because it's written in multiplication form. All right, g to the third power, as we just learned, g to the third power is repeated multiplication. So the number that is being repeatedly multiplied is the base, and the exponent tells us how many of those bases are being multiplied together. So g to the third power is g times g times g. Okay, big difference here. Repeated multiplication and repeated addition. So I'm going to ask you this on the test. I'm going to ask you to write 3g as exponential form, as expanded form, and then I'm going to ask you to write g to the third power in expanded form, and you have to understand the difference. Multiplication, like 3 times g, is repeated addition. Remember, we talked about this yesterday. Repeated addition. Well, not yesterday because you had a snow day, but on Tuesday. Repeated addition is multiplication. And then g to the third power, well, g to the third power means repeated multiplication. So if you see exponential form, you should think, well, that is repeated multiplication. Okay? Very important that you know the difference between those two, and I'm going to ask you that on the test. All right, let's move on. We can also have repeated addition using fractions. Nothing changes here. Repeated multiplication using fractions. We look for the number, in this case the fraction, that is repeatedly multiplied. So the number that is repeatedly multiplied is 1/2. That is our base. And I'm going to put that base in parentheses because I want to make sure that everybody knows that 1/2 is the number that is being repeatedly multiplied, and it's happening 3 times. So that is my exponent. So 1/2 cubed, or 1/2 to the third power, tells me that we are repeatedly multiplying 1/2 3 times. Number 10, write the expression in expanded form and then evaluate. Well, let's write it in expanded form first. If we write this in expanded form, then I am going to look for the number that is repeatedly multiplied. That is 2/3. So 2/3 is the number that's repeatedly multiplied. The exponent tells me how many of those are being multiplied together. And there's 2, so I'm going to add a multiply by 2/3, and that's expanded form. Now, we need to evaluate these two. Well, when we evaluate, let's start with number 10. When we evaluate, all we're doing is finding the answer. We're simplifying the expression. So when you multiply fractions, we multiply numerator 2 times numerator 2. Well, 2 times 2 is 4. And then we multiply denominator times denominator. That's 3 times 3. And that's a 9. So our answer when we evaluate this expression is 4/9. When we look above, we're doing the same thing here. Now it's in exponential form. So remember what this exponential form means. It means 1/2 times 1/2 times 1/2. Well, isn't that 1 to the third power? Wouldn't we be multiplying 1 times 1 times 1? If we look over here, numerator 1 times numerator 1 times numerator 1, we would get 1. So 1 to the third power, 1 multiplied repeatedly, 3 of them. 1 to the third power is 1. So that's my numerator. And then the denominator would also be multiplied 3 times. So 2 times 2 times 2. Well, that's 2 to the third power. So 2 times 2 is 4, times 2 is 8. So this expression, when you evaluate it, is 1/8. And notice what essentially happens is the exponent outside of the parentheses goes to both the numerator and the denominator, and it turns into 1 to the third power over 2 to the third power, and then we can calculate that and evaluate those expressions by multiplying, repeatedly multiplying. All right. Here is a table that you'll see on the test as well. You're given either exponential form or expanded form or standard form, and you have to find what's missing. So the first one's done for you. 3 to the second power. We also call that 3 squared. 3 squared. And 3 squared would mean repeated multiplication. The base is 3. It's repeatedly multiplied. 2 of them are multiplied together. So 3 times 3 then is 9. So we just evaluate for standard form. All right, now we're just given expanded form. So I need to write it in exponential form. Remember, exponential form means you need to have an exponent. So we look for the number that is repeatedly multiplied. The number that's repeatedly multiplied is a 2. So that's my base. And then I look for how many of those 2's are repeatedly multiplied together. And I see 1, 2, 3, 4, 5, 6 of them. That is my exponent, 2 to the 6th power. And then to evaluate and get the standard form, we just have to multiply. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So the standard form is 64. All right, let's go to exponential form, 4 to the 5th power. 4 to the 5th power means that I have a 4 that is being repeatedly multiplied, and I need 5 of them. So it's 4 times 4 times 4 times 4 times 4. Ran over a little bit. And then we'd have to multiply that. Well, it's going to be a big number. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. And 256 times 4 is 1,024. You can check my math. I think that's right. But it's a big number. Exponential form turns into some big standard forms very quickly. The power of exponential growth, and we'll talk about that another time. Okay, moving on. Next we have expanded form. So I look for the number that is being repeatedly multiplied. That number that's being repeatedly multiplied is a fraction, 3/4. And it's being repeatedly multiplied with 2 of them. So in parentheses, I'm going to put a exponent of 2 outside of the parentheses, saying that 3/4 is repeatedly multiplied. Let's stop there for just a second. If I wrote, well, let me back that up. If I wrote 3/4 squared, well, that means something different. That just means that the 3 is squared. So when I evaluate this, this would mean 3 squared over 4. I wouldn't square the 4 because it didn't tell me to. The exponent belongs to the 3. When I put the exponent outside of the parentheses, it belongs to whatever's inside of the parentheses, which is what I want. So this would not be writing 3/4 over 2 would not be correct here because 3 is not repeatedly multiplied. 3/4 is repeatedly multiplied. And then to evaluate in standard form, we just multiply numerators. 3 times 3 is 9 over 4 times 4, 16. All right, get the idea there. Let's go back to, let me see if I can erase this quick. Yeah, let's go back to number 2 here, and we'll talk about 5 cubed in all 3 forms. So remember, cubed means to the 3rd power. So I'm going to write 5 to the 3rd power. That is exponential form because it has an exponent. I'm going to write this in expanded form by saying what is being repeatedly multiplied. The 5 is being repeatedly multiplied, and there are 3 of them. So there is expanded form. And then standard form, I'm just going to evaluate. I'm just going to tell you what that answer is. What is 5 times 5 times 5? It's not 15. A lot of people make that mistake. We're not adding here. We're multiplying. It's 5 times 5. That's 25. So we're doing this. We're breaking it down piece by piece. 5 times 5, 25. Now I have 25 times 5. And 25 times 5 is 125. Okay, when we evaluate. All right, moving on. One student thought 2 to the 3rd power was equal to 6. What mistake do you think he made, and how would you help him fix it? Pause the video here and take a shot at this. See if you can figure out what went wrong. He's wrong. 2 to the 3rd power is not 6, but I want you to tell me why. All right, you should have written the exponential form 2 to the 3rd power, or 2 cubed. 2 to the 3rd power means 2 times 2 times 2. And if we break this down piece by piece, we find that 2 times 2 is 4. And then we have to multiply by another 2. And 4 times 2 is 8. So what did the student do wrong? Well, the student didn't interpret the code, did not interpret exponential form. 2 to the 3rd power does not mean 2 times 3. And that's the mistake that many students make. This is never a multiplication problem between the base and the exponent. It's the exponent is an instruction. This exponent is an instruction. It tells you how many bases to multiply together. It's not used for calculation. It just tells you how many 2's to multiply together. So this is a mistake that I see often. Don't fall prey to that. Understand the code. We've got to all talk the same language. Remember, multiplication is repeated addition. Exponents now, we know, is repeated multiplication. Hope that helps. Talk to you next time.